What's up, everyone? Welcome to today's live stream. It is November 10th. I cannot believe a third of November is already gone. I do not understand how that happened. Probably because I've been live streaming every single day and it's just been making time fly. This is a lot of fun. So today, we're going to be starting a brand new project today. Brand new. And in this project, well, I should actually rephrase that. This is me bringing back a project that I worked on, I think it was like 5 years ago. 5 years ago, I kind of started doing JBV Creative, but I didn't really understand how the internet worked. So I didn't really have a reason to do what I do now. So now that I'm kind of more established and I have something going, it's time to start a brand new project. It is a really fun project, a project I'm very excited about. And yeah, so I guess the best thing to do is just get right into it. This is going to be a robot clock, as the title of this live says. And that's kind of a vague description of what I'm doing, but we're going to hop right onto the whiteboard here, and we're going to just start sketching out the idea. As I mentioned earlier, I've already built like a first prototype of this like a long time ago. That thing is since completely destroyed. It's gone. I don't even know if I have pictures of it, honestly. That's how noob I was 5 years ago when I started doing all this stuff. But let's get right into drawing a sketch, and then, we can chat a little bit more about what this is going to be, what's involved in the design of this project. But like all good projects, this always starts in a sketch. So let's get right to that. And I'm going to throw some music on in the background here, just to keep things nice and fresh. And let's get into it. Feel free to ask me any questions you want. I'll constantly be checking the chat, and hopefully I fixed the delay issues, the latency issues, so I can be talking to you guys in more real time than I have been in the last 5 streams. So, what is a robot clock? Well, I'm sure that could be many different things to many different people, but to me, what this basically is, and let me just make sure I can draw in a place where you guys can see. So I'm good up to here, good to about here. All right, perfect. So the robot clock is a robot arm, and we'll just draw like the servo right here. That's gonna be driving the main arm. There's gonna be an arm like this, something coming out of it. Probably gonna have something like this going on. Yeah, we can still see it. There's gonna be another servo in the back here that's gonna connect it to this right here. That's gonna control this arm. Don't know exactly the details of that right now, but we'll figure it out. That's what this is all about here. And then there's gonna be some sort of gripper system here. That, and I don't know how that's gonna work yet, but we're gonna figure that out too. And we were actually already running out of space. Let me move this back a little bit just to give us a little bit more space. Perfect. So then there's gonna be a few of these blocks here. Not really, blocks isn't the right word, but there's gonna be like connect 4 dropper things. And so what's gonna happen is there's gonna be this robot arm right here is going to grab some marbles from some sort of marble lift that's going to bring the marbles to about here, we'll just say. I think there might be a system like this. I don't really know how we're going to do that yet either. And it's all going to be in some sort of box that you can fit on your wall. So I want this to be a wall-mounted piece. And then basically it's going to pick up these marbles and it's going to drop them into here. So this would be ours. So we'd have 0 for 12, 1, 2, 3, 4, 5, 6, 7. I guess you got to go all the way up to 12, 8, 9, 10, 11, 12. So obviously the scale of all this is really not right, but basically it's going to bring the marbles up and maybe we'll draw in a different color. And we're going to draw everything completely out of scale, but it's going to bring the marbles up like this. And it's going to drop them into here. So there might not be a 0 down there. I'm still figuring this out. But at 1 o'clock, it's going to drop a marble into here. And that's going to be 1 o'clock. There's going to be nothing here. And then when it's like 1:01, it's going to drop a marble into here. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. And I guess this is the middle of this will go up to 6 to 5. 1, 2, 3, 4, 5, 6, 5. Is that right? If I'm doing it wrong, we're going to correct it anyways down the road. I'm not playing Daft Punk. I have to be playing like stuff that's from Epidemic Sound. So nothing that like anyone's heard of, really. Just so I don't trip the YouTube algorithm to thinking that I'm like stealing stuff. But yeah, so when it's 1:01, it's going to drop a marble here, and then every minute it's going to drop another marble in here. Yeah, so every minute there's going to be marbles, and then when it hits the top, when it's 1:09, when it goes to 1:10, it's going to dump all of these marbles out, and it's going to drop a marble here. And then it's just going to continue doing that every minute, making a lot of noise, but I think it's going to be pretty sweet. So that's the basics. So like these are the things that we have to figure out here. The robot arm itself, it's relatively simple to design. There's already some like open source free stuff on Thingiverse that I've played around with. Let me actually grab it. It's right here. So it's this right here. And yeah, basically I'm going to design my robot arm off of this design. So the motors are on the side here. Put this marker down, I can explain this to you better. So there's this servo motor here. There's one that used to be here. I've taken it apart since then. This motor controls this arm section here. The second motor here controls this arm part, the second part. And then this motor controls the opening and closing of the gripper. So I'm basically going to redesign this in my own way, in a way that can integrate into this clock right here, this clock. So that's already done. The next thing that we're going to have to figure out is the mechanism for like dropping the marbles out. So basically, yeah, this is going to drop out every 10 minutes, I guess. This is going to drop out every hour, and this is going to drop out every 12 hours. So each one of these actually have to be actuated individually. So we're going to maybe make a list up here. So we have the robot arm. Can you see this? Yeah. Robot arm. 3 servos. 3 actuators is really. Then we have the number dump. That's got to be. There might be a way to do it all with one actuator, and I'm not really sure exactly what I'm going to do here, but we'll just say 3 for now. Keep it simple. And then I guess the marble feeder. Needs 1 actuator. I don't know if it's going to be a servo or what it's going to be. So yeah, that's kind of that's the basic layout of this project. You could use multiple arms, but I'm just going to use one because this is the way I envision it, and yeah, like as an artist, I get to have that freedom to do it however I want, which is great. That's the best part about being an artist, as an engineering artist, is I get to do whatever the hell I want. Yeah, so the plan for this is actually to design it and like make it fully functional, and then I was thinking that I was going to do a Kickstarter for this project. So once it's all working, throw it up on Kickstarter, and if people want to buy it, then great. Then I can sell it, and we can refine and turn it into a real product, at which point we can do some optimization, figure out the best way to do things, and ship it out as like a fully finished, like hopefully like quality project. All right. So that being said, really the first thing to do I think my first task that I want to tackle here is probably the robotic arm. I think I'm going to throw the arm first. Throw down the arm first, and then we can go from there. So, yeah, like it's always kind of hard starting a project because you're like kind of starting it from nothing. But let's just, let's start. I don't need the marbles as a time, but that's just the way I envision it. So that's the way I'm going to go with it. Like that's the whole point of this, is just to be like an interesting, different clock. You know, it's not the most functional thing. It's definitely not the best way of doing anything, but it's a fun way to do it, and that's what this is all about. It's all about having a good time, having fun. Okay, so all good projects start by stealing parts from other old projects. In this case, I need to steal some motors. So when was the last time I used some motors? I need probably the big servo motors. That's going to be from the paint flinging robot. And we're going to just make a new folder here. This is my 59th project, 059 robot clock. And then let's grab some motors, and I'm not really sure where they are in this file, but yeah. I think we're just gonna use the regular, like, crappy servo motors for now that you can get from Amazon, and I believe those are, I don't know which ones they are. Maybe these ones here. So yeah, for this one, I'm planning to 3D print like as much as I can, but I want to turn this into like a real product. So I'm not gonna like hold myself to that standard. A lot of my projects in the past, I've designed them so they're just fully 3D printable, so anyone can download them and print them themselves. This one I'm planning to create like a product that I can then sell and ship to people. And I'd be doing all the assembly myself. So it's a little bit of a different approach that I take to a project like this than something that I'm designing purely as a 3D printable part. But for now, I'm planning to 3D print it, and like I don't think that I'm going to be selling this at any scale. So when it comes down to if like 50 people buy it from Kickstarter, I'm probably going to 3D print all the parts and like have some other parts. And we'll see. Like I might add some brass to it because I really like the way brass looks. I don't really know. I don't know. This is the fun part about the start of a project though, is like we're so early on right now that it just, like there's like all possibilities are endless right now. But yeah, let's just start pulling some parts in and start building some stuff. And everything is really subject to change at this point, but sometimes the easiest thing to do is to just get started. And so for that, I'm just going to save this assembly, and we're going to pull those motors in. This is in Robot Clock. Let's make sure we're in the right folder. ROCL. That's going to be my working 4-letter title for this. Assembly. All right. Boom. Now let's get those motors in there. And so I'm starting with the motors, these motors right here. And I don't know why, that's just probably like the easiest base starting point for me. I don't know if there's gonna be like a back plate, if there's gonna be a frame on this thing. I don't really know how I'm doing it, so yeah. I don't know, maybe I'll make a frame for it, just for now. So let's draw that quickly. And I'm gonna do it really simply, just going to do this. This right here is it's Solidworks, so it's not open source. It's actually it's quite closed source. It used to be like very hard to get, but now I think it's gotten a little bit easier to get. I'm not sure like how expensive it is, but I'm pretty sure you can get it for free as like a maker copy. Like this is like a student version of it. So it's not quite open source, but it's not quite but it is free, at least for now. And we're just throwing some random arbitrary dimensions here for now. I'm just trying to get things moving to start, and we can like fix everything later. But that's why it's important to make sure that everything is dimensioned like this. We'll make that 35 as well. I'm gonna give it some arbitrary thickness for now. So we're gonna go like, I don't know, maybe 60 for now, boom. And I wanna give these walls here, these top walls, some angles, and I think the best way to do that, what is the best way to do that? You know what, the best way to do that for now is to just give it a chamfer. A big chamfer. So they're all 35 millimeters thick. So we're gonna make the chamfer 35, and that's a little bit too much angle. Maybe I was thinking 30, maybe even less, 25, maybe even less than that, 20, and maybe I don't want it to go right to the edge. I want to have like a little lip on the edge. Boom. So there's our frame for starters, and that's just gonna give us like a base point. It honestly might not exist in the final product, but it's a good starting point, frame. And let's throw that into the assembly, insert components, and then we can kind of get an idea now for scale of everything. It's gonna at least run like robot work. There's not gonna be much clockwork involved in this, but yeah. So this might be too small of a frame, but we're gonna worry about that later. Luckily, I'm not planning to 3D print the big parts here, so you know, it's a huge relief when like often I'm doing everything for 3D printing. We're gonna get another one of these, and that's gonna go this way, and then I think we're gonna get right into designing the robot arm. So I'm using this as kind of my like base design. It's gonna be bigger than this for sure, but one nice thing is I don't need to have a rotation. So yeah, this has a rotation on it. I'm working on a 2D plane, and yeah, so that's what we're gonna be based off of. And anti-V, I know that feeling so well, unfortunately. It's the worst, but it is just part of it, right? Okay, so there's gonna be a lot of just like rotating the screen around just because I have no idea what I'm doing right now. I don't know where to start. Maybe I'm gonna start with the gripper. So the gripper is just gonna be like a simple like I'll draw an overhead view of the gripper. It is definitely the exploration phase. If you're looking here, I guess we can we'll draw it right here. Gripper concept. Boom. So it's just gonna be like a servo, a small servo for the gripper, and that's gonna go directly in. I don't know if I should just like kind of like straight up copy this gripper. It's a good design. Nah. I want to do something different than that. I think I want it to be one of these. So there's gonna be like a gear here, and there's gonna be like a rack here, and maybe a rack here, and this is gonna be attached to one gripper arm like that. This is gonna be attached to another, and this is gonna be perfectly contoured to hold a marble. And so when this rotates, the gripper panels go out, and when it rotates the other way, the gripper panels come in. And we're gonna have to figure that all out, but let's start by making this guy. Let's start exploring. Okay, so I need a rack to start. And I have some racks. If I go into my gear library, and maybe we'll go with, get out of here, fruit fly. We're gonna go with, what's up, Sneaky Soup? How's it going? Maybe an M1 rack. And this is like way longer than we need it to be, but let's just first save this as gripper piece. Save it as a copy. No, we don't need to save it as a copy. Okay, we just gotta do this. ROCL _ gripper piece 1. Awesome. Happy to hear that. How's the delay going today? NTV, you were here in the last couple streams. Is it any better than it was yesterday? I changed a setting and I'm hoping that it fixed the problem, but. Okay, so for the gripper piece, let's test it. NTV, like, ask me a question. Okay, perfect. That works for me. $42. I might have not have been looking. Let's try one more time. Give me a different number. $36. How was that? It's definitely better, I think, than it was. Okay, yeah, that's way better. It was like 20 seconds before, so I'll take 2 to 4 seconds. Okay, so I'm just gonna try to get this, basically drawing this section right here. So I have my gripper rack, and I'm just gonna, this is all real basic right now. Like, none of this has to stick. It's just for me to get kind of an idea for where things are gonna go. So I'm just gonna do it this way. There's gonna be like a marble holder here. I guess we'll work on that later too. It's really, like, this is like such a challenge as like the starting point of a project. You know, like, true, yeah. No, I had the latency setting set to like normal latency, and I've now turned it to ultra low latency. So it's not going to be as like good quality stream, but it might help. It's going to help at least with the chat delay, which is good. But yeah, so the starting point of a project is really, really hard. Okay, that's good. That's good. Yeah, I have no idea what to do when I'm starting out a project. It honestly, really, this is like the hardest part for me. I have like a vision in my head, but I just got to figure out how to like turn this into like real engineering. So I'm just choosing arbitrary dimensions right now. We're gonna change them later. But that's why it's important to dimension everything, especially when you have no idea what you're doing, because then you can just make easy adjustments later. Boom. This will... Yeah, true. That's exactly what I'm doing. Just get something visual. Not think about it too much. Just get something out there. Boom. And then the last thing we need, what's wrong here? It's this dimension here. So I do want to get this to the center point, but for now, yeah, let's just do it. Before that sketch, we're going to take this body. We're going to make a plane in the center of this. And now we're going to do a move. No, not move face. Move body. This is the guy we're moving. This is what we're going to be moving. This to here. And what's wrong with that? Okay, maybe we can't do a plane movement. We're going to move this to here. Maybe we can do a center. No. Ooh, that sounds good. Oh, you're making me think about real spaghetti, not 3D printer spaghetti. Got me all excited there for a second. It's like, damn, I could definitely go for some spaghetti right now. Okay, I just want this to be centered, but it's not going to work right now. Honestly, this is like such a tricky thing for SolidWorks. Just like moving bodies in a part. But it's all good. So now we can bring this guy back over here. Perfect. And we're just gonna give this an arbitrary dimension for now. I honestly think it's gonna bite me in the butt later to not have this centered, so we'll figure it out. What's up, Murphy? I don't know if I said your name right. Is that a game? I've never heard of it before. Factorio Spaghetti. What are these doing over here? Don't need that. Oh no. Oh no. Now everything's fucked. Maybe we don't need this plane. Boom. We can just hide this plane. Okay, cool. So now we're gonna take this, extrude it, and then we'll extrude it up to here. Boom. And like honestly, I think no, it has to be shorter. Okay. Let's at least. This is like it's just so basic right now, but it is what it is. Let's grab another gear. We need a circular gear this time. Maybe we'll go with I don't know, 15 teeth, just so we can like squeeze a servo horn into there if we need to. Just save it. And this we can keep its name, ROCL _. Get rid of this. Get rid of this. And save that. Okay, and then where's our assembly here? You know what, maybe we'll make a new sub-assembly. It's the gripper assembly. Just make life a little bit easier. So we got our gripper piece, 1. We got our spur gear. And we're just getting a little bit of dimensional understanding now of what's going on here. So like obviously this is like a little big, but it's all good. And then we actually need a small servo, which I believe I can grab that from NTV. Are you a dad? Got some good dad jokes coming at me. And I love a good dad joke, so respects. Like, I don't know if you can dislike it. Sorry. Oh my God. I don't know if you can test fit tolerances necessarily, but you can see like really well how things look. Yeah, you're a dog. That's what you are. But yeah, you can't really test tolerances per se, but with a little bit of experience, you can definitely get a feel for tolerances. So I just need a small servo here, and I think we're going to use the MG, where is it? This guy, MG90S. It's the small guy. Rename it. ROCL. Uh-oh. I named this piece the wrong name. I love me some chaos. I'll have to check it out. So this guy right here, I just want to rename with the proper name. ROCL. Beautiful. Save. Now we got this. We can get our motor in there now that we have it. We need the MG90. Boom. Oh my God. We need to get rid of some stuff here. Still got some parts. Sometimes I build right off of the motor, and this is, if you see my paint flinging robot, this is the valves here. Just practice a lot. That's the best advice I can give you. I just started learning Blender actually as well, and it's a challenge, but it's a lot of just doing stuff, and then like you end up learning the best ways to do things. I don't know why I can't delete that right now, but it's all good. But yeah, just the more practice, the better, really. Okay, so we can delete everything from here, basically to here. And we're gonna just delete absorb, child, yes to all. Boom. Back to just a straight motor. Beautiful. Okay, so this is going to be mated with this. This, I don't have a hole in it yet. Well, listen, it's not a matter of if you're good enough or not good enough. If you have, like, if you're like just getting into it, you actually have better insight than I do. So, love to hear what you have to say. So I've been at this for a long time, so like, you know, I don't have that beginner's insight. Also, I learned this at a time when there wasn't a lot of, like, there's so many resources now on YouTube. Like, when I started learning this stuff, YouTube had just started becoming a thing. Okay, so let's put a mate on, actually, I want this guy right here to be origin mated. I want this to be right now the base of this whole thing, and it might not like it. Coincident, align axes, perfect. So now this, yeah, that's why. Float that motherfucker. Okay. This right here is gonna mate to this face. Perfect. And then we just need to get a distance mate from this axis to this right here. So this is one of those situations where I just like, I have to use just like experience basically to figure out the tolerances. Ah, okay. Do I call you Michelle? Are you French? Yeah, it's true. And also make sure you set to like use timeline in Fusion, because I did that once and like I like did a whole project without the timeline and I had no timeline. And like, I don't know, I guess Solidworks are just like a natural, there's always a timeline there. I'm just gonna mate this face to this face. This is really the biggest difference between Solidworks and Fusion, I think, is just the way that the mating systems work, but it's same but different, I guess. Okay, so this right here, I'm just trying to like find like, you know, just like that. Like that looks like there's too much clearance. There's gonna be too much backlash in these gears. Okay. Not from France. So we'll call you Michael. What's up, Sarah? Welcome to the stream. To tonight's stream. So for all of you who missed the explanation of what I'm doing, it's this right here. This is a robot clock, and right now I'm just working on the robot hand that will grab marbles, which will be used to keep time with this robot clock. So that looks good enough for now. Beautiful. So the next thing I need to do is make another one of these. Gripper piece, we're gonna call it gripper piece 2. And I basically just, oh, you know what, I want to dissolve this feature, yes. It's gonna cause me issues moving forward. All right, perfect. Whoa, we got 2 New Mexicos in the chat right now. Crazy. Yeah, seriously, NTV got some really awesome stuff going. So I really just need to flip this the other way. And I think I'm going to do it. I'm just gonna rotate. Yeah, if I rotate it, no. I need to mirror it, but I don't want to mirror it. We're just gonna do it this way. The old school, old-fashioned way. That's fine. I made this flipped from the way that I drew it on the board here. Yeah, you heard it right. There's robots, clocks, and we're gonna go with ball bearings. Balls, bearings. I'm just having trouble visualizing this right now. This needs to be like this, but I went the other way, so it's gotta be like this. It's all gonna make sense soon. Boom. Okay, we're gonna give it similar dimensions. Boom. Ball bearings. Keeping this PG, but not actually. I did swear a couple times. We're gonna keep it classy at least. One more, maybe from here to here, and I guess we need one from here to here. There we go. That's 40. That's gonna be, get rid of this guy. Yes, thank you, NTV. Basically it. The Prusa is the best out of my printers. I just fixed my Ender today. It is working good again. So that's something I could be excited about. I have now back to 4 working printers. So I have an Ender 3. I have a Prusa MK3. I have an Anycubic Mega. All FDM, and I have a it's a Lawsbot Taz Pro, which is a sweet machine, just so expensive. It's crazy. Okay, gripper piece 2, that comes in here. That goes this way, and then we can like line some stuff up. Boom. Maybe we'll go like parallel mates like that. Boom. That's crazy. Maybe there's just 2 New Mexicans in the chat right now. We're gonna go a mate from and Sweden. I don't know. Yeah, it's kind of jumping. It's like saying that there's only 2 people, but I feel like there's more than 2 people here. Definitely more than 2 people here right now. Yep, Belgium. I don't know, but this is going to be a clock that is likely powered by the internet. That is my plan for right now, or at least by like a universal time. I don't know if it's a sensor, something that plugs into Arduino and like keeps the time like really really well. Because like I don't want this thing losing time. It's the Ender 3 V2. I didn't even know there was a 3 plus. It's not gonna have alarm because it's gonna be dropping marbles like steel ball bearings. It's every single minute you're gonna hear this. Yeah. So no alarm. And then like every 10 minutes, they're gonna dump a whole bunch of marbles out. So it's gonna be pretty loud, I think. It might be really obnoxious. It might not be very functional from that perspective, but it is what it is. Thanks, Mr. Boy Yeet. Yeet 2. But yeah, this is gonna be the next like week or so. Just coming up with this project, how we're gonna do the engineering here. Yeah, it's gonna be fun. Yikes! I want this to like hang on the wall, but that's another way to do it. Just like every minute, shoot a marble at the wall, and like have a modified sort of like force ability. So sometimes it can shoot a hole like right through a piece of drywall. You guys are getting all the creative juices flowing here. It's great. Okay, what am I trying to do? I'm trying to find this axis and made it to this right here, and with a distance of 8.75, I think it was. Boom. Perfect. And then now we can throw down some rack and pinion mates. But obviously we need to make some changes to this. So first things first, I'm going to make these racks a little bit shorter. Yeah, it tells time, but it only works as long as there's drywall there. You gotta replace the drywall like once a day. Otherwise the clock will stop working. Destruction. Okay, we're gonna do the same thing on this guy here. Boom. Nope, went the wrong way. All right, I actually want to dissolve this feature too. Yes, break the link. Break that link. All right. And then we'll worry about the link somehow. That'd be fun. Instead it's a cup of coffee mechanical clock. You guys are like really, you're trying to like destroy me right now with these ideas, eh? I think we're gonna be struggling to just make a robotic clock in the first place. Okay, let's throw some, where is it? Right here. We need the axis on this, and I guess we need any flat surface, but let's just see. Where is mechanical mates, rack pinion, that and this, and no, that's the pinion gear. Okay. Show us our axis. The rack is this. The pinion gear is this axis. Boom. Oh, come on. Okay. We need to put a hole in this. Solidworks loves messing with me a little bit. So I went to school I'm from Canada, so I went to school at a little school called University of Guelph, which is like 45 minutes out of Toronto. Not a well-known school, but it was a good time. Two feelings, eh? I think, yeah, we've got the robot, the balls, the ball bearings, and the robot arm. Okay, so we need a pitch diameter, and the pitch diameter is, I believe, 15? I can't remember what I used here. We'll confirm after. Yeah, 15. So when this rotates, look at that. We got ourselves a rack. Dope. Okay, now I gotta do the other one. Can't believe there's 2 people from New Mexico here. Never been to New Mexico. I actually don't know anyone from New Mexico. I only know one place in New Mexico. I don't even know how to say it. Las Cruces? Well, Sneaky Soup, thanks for hanging out. I hope to see you in the next one. I guess I didn't. That's interesting. Very interesting. But we need to fix that, mate. It needs to be... What's the problem? Maybe we have to reverse it? No? What's going on here? Okay, this bottom one's right. Let's get this top one to be right. That's weird. The New Mexico JBV Creative Fan Club. I love it. Give me a good excuse to come out to New Mexico, that's for sure. Rack, pinion. I don't know what the deal is here. Let's just try this one again. This needs to go this way. This one goes this way. That should be right. This is giving me some trouble. All right, well, anyways. We'll figure that out when it's important. You post a picture of that spaghetti in the group. In the Discord group. So now, I just have to change some dimensions. 40, we're gonna make that 50. And we're gonna make this 30. We're gonna make this 25. $27. All right, fine. 26 and a half. All right, there it is. So this is gonna open, this is gonna open, and then they're gonna close together, and they're gonna grab the ball bearing, which we're gonna make now. But this is ROCL gripper assembly. Beautiful. Get rid of this. So yeah, I think we're gonna keep working on this for like maybe like another half hour, and then I'm gonna finish that sculpture behind me. I made some really large improvements from yesterday, which I'm excited about. I was honestly, at the end of yesterday's stream, I was like feeling like despair. It's so hard when something doesn't work, but it's all good because we fixed the problem. Okay, let's get the gripper in here, boom. And let's just see what kind of scale we're dealing with. Yeah, it looks weird right now, but it's gonna come together. I'm gonna make this way bigger, I think. Maybe like 275 by like 350. Maybe even bigger than that. But yeah, let's let me get our ball bearing in here. That's an easy one. Like the process kind of changes like depending on how much of a vision I have for what I'm doing. So yeah, there's like no one way that I do anything, but often I'll just like put the parts in that like I can visualize first, and then yeah, like you use that visualization to then build the next parts. And yeah, kind of like what you said actually. Where is my calipers gone? They're over here. So this marble, oh, that's the wrong one. I'm planning to use these steel ball bearings. They are 12.66-ish millimeters in diameter. We're gonna go 12.65 because I like that number better. Oops, wrong button. Okay. Do this, do this. Features, revolve boss base. Boom, boom, save it as ROCL. Ball bearing, and maybe we'll just specify 12.65 millimeters. Cool. So now we have our ball bearing, and that's going to give us another point of reference for scale. Maybe we can make some like ball bearing that we'll make the number blocks now. Yeah, so like sometimes like at this point I'm just starting with the easy stuff. Just I'm letting my I guess my subconsciously deal with the hard stuff right now. And I'm also just these are all kind of just placeholders for everything. Maybe it's the best way for me to start. So the ball bearings are gonna fall into this. They're 12.65. Let's give them a little bit of clearance. Like we'll make this 12.9. Just because I don't like the 13 dimension. It's like purely just a thing. And this is 3.5 as well. And I don't know how tall I want them to be, so I'm just gonna make it the height 12.65 of a ball bearing, and then I'm just I don't know why I'm doing it this way right now, but it seems like the right way to do it. I'm gonna linear pattern it, and this is just because each one has its own height. This is 12.65, and spacing and instances we need 12 for the hours, and then now I can make configurations. Add configurations. This will be minutes. This will be tens, and then all I have to do is change this one dimension right here and make sure I select this configuration. And so the middle one, I guess, is 5, but we can always change this after. Boom. Oh, ROCL. These are the number stacks, we'll call them. Perfect. Yeah. And then we'll make the one for the ones. Add configuration. Ones. And this. This is 9, I believe. So let's bring those into the assembly now. Insert components, number stacks. So this is the default, which is the hours. Boom. This is the ones. We're gonna make that the tens. Perfect. And then there is the ones. Okay, cool. You guys are welcome anytime. Down for the New Mexico crew. Let's space them out. I don't know. 25 for now. And this one. 25. Perfect. And then align the tops. Cool. And then now we can bring that into the frame. So things are starting to kind of come together slowly. Awesome. Well, I'm so happy to have you here. And I'm happy to, I don't know, help you learn and stuff. I hope I'm helping you learn. The clock, it might have LEDs. It could be interesting. Maybe I can have like LED strips in the back here, and like when the marble comes into whatever section it's coming into, it would like kind of like block the LEDs. Marble, ball bearing, that's gonna be interchangeable, those words, for the upcoming streams. So let's just throw a axis, boom. And then we can mate this. Maybe we'll throw an axis on this guy too. So this reference geometry is very important often for mating things together. Boom. And I think I'm going to make these guys transparent for the time being. So look, we now have our first marble. Boom. So I'm not sure if I want like, yeah, maybe I want the tops to be lined up and the bottoms to not be lined up. That's cool. So there's got to be some sort of like reservoir in the bottom here that holds the marbles, but like we're not gonna get to that yet. Let's get back to this robot arm, which I said I was gonna start with, but I obviously did not do it. But yeah, let's do that next. So new part, and we're just gonna keep this really simple right now. I'm just gonna make a very simple shape. Boom. Maybe we'll make this 40, and we'll make this length some arbitrary dimension of maybe like 150, and we're gonna make an arbitrary thickness of. Thank you, Sarah. I appreciate it. ROCL arm. So we'll go bicep and forearm. Real solid engineering terms here, guys. Insert components. Bicep. It's a little bit thick. It's a little bit too thick. That's gonna mate to like this guy maybe. And maybe we'll make it a little less thick. And it doesn't need to be so long either. Much appreciated. I don't know. Can one of you put the link to the Discord in the chat? I don't know how to do it. I don't know if you can you even do that? But Mike, we would love to have you in the Discord, part of the conversation. Amazing, ATV, I appreciate it. And let's make the forearm. We're just gonna copy that into forearm. That's a good question. I have absolutely no idea, but I guess we'll find out when it's all plugged in. Like these motors here are 6 volts, and I believe they use like 200 milliamps. So if we're pulling out the calculator, 6 volts times 0.2 amp, oops. 6 times 0.2. That's when they're like full load. 1.2 amps. That's actually a lot. It's gonna probably be a lot. It's not gonna be the most efficient clock on the market, that's for sure. It's definitely gonna need to be plugged in. But it's a piece of art, so we can make some sacrifices. Yo, Kurt, what's up, buddy? Everyone, Curtis is one of my friends from engineering school. And he works for an automation company, so I was talking to him for another project that I can't talk to you guys about yet, about a robotic arm, but that's not what this is. This is different, actually. But everyone say hi, Curtis. So we're just kind of like, we're doing some hack engineering right now. Just hacking everything together, literally. Boom. Let's make that to this. Boom. Pablo 2.0, exactly. This is a lot more Pablo than what I was talking to you before. Pablo was a robot that Kurt and I actually built long before we had any idea how to build robots. And we built it to write names and stuff. It was like a huge undertaking for us at the time. But it got the job done. So if you're wondering why this is Spanish, the answer is I have no idea. Honestly, just going to school got me into engineering. I really didn't know what I was gonna do before I started engineering, and I went to school for arts, like general arts, and then ended up taking a bunch of physics classes, which led me to engineering, which was great. And then once I started, it was just like, wow, there's so much fun stuff I can do with this, including build Pablo, the name drawing robot. All right, so here's our robot right here, and really the only thing is it has to be able to reach the furthest number right here. So let's just hold this in place right now, boom, and see. So yeah, with the gripper on there, as long as it can reach the furthest and the closest, that should be good. Let's put this hack gripper into place right now. Maybe I'll do this. We're gonna make a new part. Oh. I need to open my gripper assembly here. Open a sub-assembly. Thank you, Sarah. It's definitely, it's coming together already, which is great. This, I actually want to, I think I want to turn this all this way. Yeah, well, robot arms are basically just, or excavators are just robot arms. Mr. German Zabata, enjoy your night. Thanks for stopping by. So how do I flip this sideways? This is going to be a little bit annoying. Okay, let me see if I can do it. Hold on. Oh my god. No, you cannot print metal in these printers. Like, these are very basic printers. They can only print plastic. Yeah, honestly, me too, actually. It all started in high school physics. High school physics is great. So I just need to figure out what's constraining what to what here. That's to that. So it's this mate we gotta change. We're gonna grab this, and we want it to be parallel to this. Perfect. Boom. And actually, I want that to be the other way around. There we go. Okay, let me see if I can, oh my god. See ya, Mike. Take it easy, have a good night. I hope to catch you in a future stream. I think I gotta log into the stream. And then I got this right here, and then I can get the link from here. Copy. I wonder if there's a way for me to like pin this to my live streams. There might be. There we go. There's the Discord link. Yeah, that's actually a way better idea. I'll post it in the description moving forward. But it's here for now. All right, let's keep going. So we got our gripper. That's a funny question. I actually never thought about what my favorite robot is. Actually, I know the answer. The answer to that is very easy, actually. The answer is... Oh, does that one expire, that link? Shoot. Did that one expire right now, or is it good enough for now? But yeah, my favorite robot is Wally, by far. Wally's dope. Okay, so just for now, I'm just going to attach this basically directly to here. 10. Boom. Boom. Axis. Boom. This is kind of like a hack way of doing it, but today is just a day of hack. Okay, perfect. Thank you. I appreciate it. So we need my gripper, servo, axis. That's going to mate to this right here. Boom. And then we're going to put this in the middle here. So we need this and... Oh, true. Okay, cool. Mike is still here, guys. Where's my forearm? Boom. We need this mate here. Boom. Boom. Okay, so now we have ourselves a really basic robot. Sweet. So we can get a marble there. We're gonna have to pick it up like here maybe. It's gonna drop it here. It's gonna grab another one, drop it here. You can reach here. Sweet. What's up, civil engineering pros? Could that be 3D Printer Academy's other channel? Yeah, knew it. What's up, Steven? Nice. Okay. Honestly, guys, I'm so pumped with the progress that we're making right now. Yeah. So, I think we're gonna call it on this for now because my brain's hurting. And we're gonna go into just finishing that sculpture that we made yesterday. So yeah, let's close this off, and we can put that sculpture together because I made some changes to it, and it looks way better than it did yesterday. And I'm gonna show you what those changes are. It's really basic. And then tomorrow we will come back to this robot clock when it's hurting my brain a little bit less. It's a lot. A straight hour and 20 minutes of brand new project CAD, that hurts the brain quite a bit. But okay, let's go take a look at this guy. Thanks, Sarah. Honestly, we're like not even like 10% of the way in though. So yeah, it's not quite there yet, but it's coming along. But I really, really want to put this thing together because how do I show this to you? I want to show you what it looks like right now. We're gonna show you here. Look at this. How sick does this look? Can you guys see it? So I like routed the strings through this right here. For anyone who's watching yesterday, this is the new one. This is the old one. So yeah, let's get this all lined up on the wall and then we can go from there. Let's do it. So I'm going to take you, turn you this way. Try to get you a little bit higher up like that. Boom. And I also fixed the wedges too, actually. So Neptune is not here, but he's been throwing me some incredible suggestions. So shout out to Neptune. If you're watching this when somewhere offline, shout out to you for like really getting my brain going in the right direction. So let's just start by hanging this up right here. And maybe let's pull this light over. You guys get a little bit better lighting. There we go. Maybe we can make it brighter. Nope. This will go right here. Cannot believe I just hit that. Nice. Cool. So now we have the ability to do this actually, which is sweet. I can give you guys a close-up. See the way that the strings are routed now? They're coming through these holes right here. So everything is so much more organized in there that nothing's tangling. It's way better. So I'm going to try to keep jumping back to see what's going on in the chat, but if I miss anything, just yell at me. Yeah, seriously, where is Neptune? What the heck, bud? Okay, so these just go into these holes here, real simple. Boom. can turn this sideways. I think I'm gonna give you the full screen view of this. Hold on. Yeah, so much cleaner. Okay, if I do this and turn this off and have to reactivate this camera. I did. I fixed the wedge and it's so much better. Okay, cool. So now I just gotta flip it this way. There we go. So the new wedge, let me grab it actually, just still in the printer. As per Neptune's design, the new wedge has a hole in it and it makes life so much easier. So I won't be dropping them, which is great. Yeah, Mrs. B, I had to restring the whole thing, but it's so much better now. It's worth it. Way worth it. I wish I had more light in here. Maybe I could turn this light on for you guys. Oh wow, that's way better. All right, sweet. Okay, great. I actually don't even need this light anymore. Okay. So yeah, this whole process is going to go so much quicker now, which is great. Got that spooky music going right now. I love it. Boom. This is the only problem when you do something that requires 16 of something, you have to do everything 16 times. But it's worth it for the final result, so boom, there's 16. Whoa, wow. It's like an arm workout. It's okay. This will exist on YouTube forever, so yeah. Neptune will get the credit he deserves. Okay, so next up, I'm just going to plug in my glue gun quickly. Get this chair out of the way. Light out of the way. Okay. So, you guys ready for this? So, same process. Move the furthest thing away. Boom. Make sure it's tight. But here's where the fun begins. You just throw this through the hole in the wedge, just like that. Grab our wedge spacing tool. That pops on. That's all the same as yesterday, but this is makes life so much easier. You basically just take the wedge now. You pop it in there. And then make sure the string is tight, and then boom. In. Oh my god. It was like almost not even worth me trying yesterday. Because it's just so much easier. Today is fun because it's just so much easier. Like, it's satisfying compared to yesterday. Okay, next. Adjust string. Insert wedge. Spacer. Dangler. Just like that. There's one fix I could have done is I could have put the hole a little bit higher, then it would have dangled the right way, but honestly, this is a huge improvement. Done. And I'm not cutting the strings all the way right now, just in case I need a little bit of slack. On to the next one. Well, Steven has come back to his normal self, eh? His alter ego has left the stream. Beautiful. I haven't dropped a single wedge yet. It's amazing. This I can probably bring closer to me. Spacer. Nice. Wedge. Nice. Oh yeah, got the flow. What an eclectic mix of tunes, eh guys? Oh, you've never met her. Miss Space Her. Good lady. Oh wow. I cannot believe how much I was struggling yesterday. Just like how much just a simple fix makes this so much easier. There's my first wedge drop, but we're good. Still good. Alright. Boom. Dangler. Boom. Pull it tight. Jam it in. Keep on moving. Oh no. This wedge is too loose. Why are some of these... Oh, it's so frustrating when things aren't printing consistently. This wedge is too loose. It shouldn't be. It should all be the same. It's like not terrible, but it might not hold, which is like frustrating. But maybe we'll throw a dab of hot glue on that one. It is definitely better than it was yesterday, so that's good. Alright, next. That's better. Yeah, it's inconsistent. You have to fix that. This one's another loose one. That's frustrating. It's like a serious arm workout. Oh my god. Yeah, I don't know. I'm going as fast as I can, but this will be on YouTube afterwards. So as ANTV said, you can watch this after. Yeah, I know it's great to have you here live. It's way better, but you gotta get your daughter. You gotta grab your daughter. Yeah, I'm gonna keep going though. I'll try to go as fast as possible here. It's cool. You can see the sine wave shape sort of forming at this point, which is really, really dope. Cool. Okay, keep going. We're gonna get the tunes going. I suppose so. I guess I wouldn't know. I'm not a dad. Not yet. But hey, Steven, the volume, the sculpture itself, the sound of the sculpture itself is just as much part of the sculpture as the actual. What am I trying to say? I'm trying to say that the squeaking is part of it. Let's put on this playlist. Random playlists. Next. So one problem that I'm noticing, like right off the bat, is that these are still not heavy enough to like really put tension on the fishing line. But fortunately, I think we're still gonna get the effect that we're looking for out of it. So that's good. Could be way worse. And maybe after when I WD-40 everything to try to deal with the Sonics soundscape effect, we might be able to WD-40 where the fishing line goes through the holes, and that might help with that problem as well. Nice, now we're flowing. Three to go. Two to go. Two to go? Yeah. But I'm missing one of my dangly things. Classic. Oh my god, look who's here! Oh, sorry guys. Wow, what's up Neptune? Welcome to the stream. Yeah, so thankful for the idea. Neptune, you got some serious shout outs. Another thing, actually, another one of Neptune's ideas was to have these holes. We kind of came up with that in parallel today. Right as I finished designing it, he sent me an email suggesting that I do those holes, and he didn't know. So we're on the same wavelength here, which is great. lost my marbles. Lost my marbles, guys. I also lost one of my danglers. I don't know where it went. So, we're going to add a new marble to this guy. Boom. And we gotta find our missing dangler. Which could just be gone forever at this point. That's often what happens in this place. Yeah, I think I lost my marbles a long time ago as well. Did I drop it? Did I put it down somewhere and lose it? They're cylindrical, so they can roll to places. I don't know, guys. I could print a new one, but it'd probably be like a 20-minute print, so you know what? I think at this point right now, we can at least see this thing working, which is cool. So at least this guy right here, what do we do with you? That's so frustrating. Okay, for now, he's just gonna chill on this. Okay, let's see if it works. I'm gonna address that squeaky issue first. Oh my god. I literally can't find anything. Where's my WD-40? This is WD-40, the gears and stuff. It makes a huge difference, surprisingly. Another WD-40 there, a little bit there. Get a little bit on the shaft here. Wow. Amazing. Okay, I think we need to throw this last angler in, so come on. Where are you? Where are you? Nice. Yeah, that's one of my favorites. No judgments at all, guys. Like so frustrating. Like I need to learn to like keep things organized, you know? But I'm not really that good at that. But yeah, Sarah, thanks so much for hanging out, and I hope you have a great night. And I don't think that we're gonna get a chance to find this last dangler. But it works. That's pretty sweet. That is so mesmerizing, so satisfying. I'm actually surprised how much you can feel the weight in the crank. It actually takes a little bit of force to get this thing to spin. Surprising. But I'm so happy with the way this turned out. Yeah. Cool. That's dope. All right, guys. Yeah, there are a couple that are just slightly off, but what can you do? So I guess what I'm going to do is at least these wedges have been the most annoying thing, but I think one problem with those danglers, one change that I'm going to make is not open. Let's open them. Danglers. Where's the dangler there? So I'm gonna adjust this wedge. I'm gonna make this distance like 0.1 even. And I'm also gonna make them longer. So I'm gonna make this even like 15 maybe. So now, isolate that, let's see. Now we can pull everything else up a little bit. So maybe we'll go to 11 on that. Maybe I want that to be a little bit bigger even. Like, I'll go to there. And then we can raise this up too. +4, boom. Cool. So that's gonna make it a little bit easier to set the danglers, and hopefully they'll wedge a little bit harder than they were before. And then, yeah, oh, it's still here. And then, yeah. So let's save this new version. Dangler, yes, yes. Selected bodies, okay. Grab this wedge, save it. STL, dangler wedge, save, yes, yes. Selected bodies, okay. We can throw it into the slicer, import, dangler wedge, dangler, boom, no. Put that on its side. This is probably like a, I don't know, let's see. I'm guessing 20-minute print. 30-minute print. Okay, so we're gonna print that, and yeah, basically this project's done. So we're gonna count that as a finished project. We're gonna count that as a stream for today. So I appreciate you guys all sticking around, having a good time. ATV fixes spaghetti, so like, yeah, everything is right in the world right now, which is great. So yeah, have a good night, everyone, and I hope I will catch you in tomorrow's stream. And I love you all. Peace out.